In class 3, we talked about linear perspective, uh, 1, 2, and 3-point perspective. And as, as was stated, it has to do with the 3 dimensions, uh, width, height, and depth of an object, and trying to create that 3-dimensional depth on a 2-dimensional surface. So with linear perspective, we work with a mechanical process using a horizon line and vanishing points. The demonstration I'm going to do for you is just a 2-point perspective, because I think most of you understood the 1-point perspective. And since your exercises have to be done in 2-point, that's the one I'm going to review for you. So again, the only dimension that is parallel to the picture plane is the height dimension of your object. So in order to create a simple box, the first thing we want to do, and we're going to draw this below the horizon line just to make it a little easier for you to understand at this point, is we're going to determine the height of our object. So that means that the width of our object, or our cube, is going to go from the bottom of the height over to the right vanishing point. The height, you will go to the top of the height and create another guideline to the vanishing point, and that will give you the dimension or the width for your box. In order to get the depth of the box, you're going to go to the left vanishing point from the bottom of the height and from the top of the height to the vanishing point again. Now normally there are measuring lines that deal with true linear perspective, but for our purposes we're just going to do this by visual process. So we are going to just arbitrarily, if it looks right, is draw in the height for the back of the box on your drawing. Once you have that, and again it should be parallel with the picture plane, you go to the height of the back of the box, and that will decide, by going to the right vanishing point, it'll decide where the line falls or where the edge falls for the back of the width of the box. In order to get the depth of the box in the back, we have to go to the left vanishing point. So then that gives you your box. Now I'm going to just outline this in red so you can see what we have. So again, just to review, we start first with the height of the front corner of your box. Then we draw a vanishing point, or then we draw a line from the bottom of your height to the right vanishing point, a line from the top of your height to the right vanishing point, and that gives us the face for the width of your box. To get the depth of your box, we draw from the bottom of your height again to the left vanishing point, from the top of the height to the left vanishing point, and that will give us the dimension for the depth of the box. Again, we arbitrarily visually decided where the face of those depths and widths would end, and then we drew from the back of the depth to the right vanishing point, because that is the line that is really parallel to the front of the width. So that is your back width. And then the depth, in order to find the depth, we draw from the back of the height of the width side and draw over to the left vanishing point. And that gives you the edge for the back of the depth. If this was drawn absolutely parallel, these lines would be perfectly equal in distance away from one another. All right, now this is where we start to get tricky, because what we want to do is we want to make this an invisible box. So we're going to draw a guideline to the right vanishing point, another guideline to the back vanishing point, and that shows us where the corner of this box is. And because we've drawn this right in the middle of the page and right in front of us, it turns out that our back corner of the box is almost in line with the front height of the box. If the box were over here or over here, you would see things adjusted a little differently. So that is your basic 2-point perspective drawing a cube. Now, once you have a cube, everything is based on that. We need to draw a cone and we need to draw a cylinder. But you need to be able to draw the cube first in order to understand how to draw the cone and cylinder.